Hello friends, this is Ritu Gupta. We'll be taking up algebraic expressions in today's session. Let's first try to understand what is algebra and then we'll move on to algebraic expressions. So algebra is a branch of mathematics which uses letters and symbols to represent the unknown quantities. An algebraic expression is an expression which is built by combining numbers and variables in the form of alphabets or symbols using the arithmetic operators like subtraction, addition, multiplication, and division. Some of the examples are written here like 5x plus 3y plus 4, 7p raised to power 5 plus 6pq plus 9, and so on. These are the examples of algebraic expression wherein you will see that the numbers are combined with the variables like x, y, p, and q, etc. to form these expressions. Let's now try to understand the different components of the algebraic expressions. Different parts of the expressions which are added together are called terms. Terms are only added together. So it's very important to understand that even if you see a subtraction happening, then the negative sign which you see is actually taken as a part of the term. So we say that a positive term and a negative term are added together. So if you look at this example, there's an expression saying 2x square plus 3xy plus 9. And in these there are three terms. We can clearly see that 2x square is one term which is added to another term 3xy, and that is added to another term 9. Now 2x square is a term which contains a variable x. 3xy is another term which contains two variables x and y. And 9 is a term which is actually constant. It does not have a variable along with it. And the coefficients here are 2 and 3. So all the alphabets that are used in this expression are variables. If we change this equation to 2x square minus 3xy plus 9, then the terms would be 2x square and minus 3xy and 9, and these three terms are actually added together. So it is important to understand that in an expression the terms are only added together. There are no subtractions happening in the terms. Within a term, numbers and variables are combined together using multiplication or division operation. So we are saying in the term 2x square, in this term 2x square, we see that a number 2 is multiplied with the variable x, second power of x in this case. So continuing with the components of algebraic expression, each term can therefore be termed as the product of factors. 3xy in the above expression can be said to be a product of 3x and y. And the variables here in this picture that you might be thinking that, why is this picture coming up with in the algebraic expressions? So what we're trying to do is that the different components shown in this picture are compared to different variables that we may have. The numeric factors in each term are called the coefficients. In this example, 2x square plus 3xy plus 9, we have 2 and 3 as the coefficients of x square and xy respectively. The terms which do not have any variable in them is called a constant term. So in the above expression, we had 9 as the constant. Friends, now let's try and understand the difference between like and unlike terms. The terms which have same algebraic factors are called like terms. We'll take an expression as an example, 3xy plus 4x minus 7xy plus 2. Now in these two terms, 3xy and minus 7xy, these two terms, if we consider the factors, for term 3xy the factors are 3x and y, and for the term minus 7xy the factors are minus 7x and y. So we can see here that the algebraic factors of both these terms are x and y, so these are like terms. The numeric factors of the two are different. In one case it is 3, in the other case it is -7, but the numeric factor does not decide the term to be like term or unlike term. It is only the algebraic factors which will be the deciding factor. So in this case, the algebraic factors being the same, these are like terms. Now let's see what are unlike terms. The terms which have different algebraic factors, they are called unlike terms. And when we say different, what we mean to say is that they may have one or two common algebraic factors, but all the factors are not the same. So that is where we call them unlike terms. Let's take an example here of the same expression. In this case, if we take the term 3xy and 4x, so we'll see that the factors for 3xy are 3, x and y, whereas the factors for 4x are 4 and x. So now since the algebraic factors of the first two terms are different, because in one case the factors are x and y, and in the other case the factor is only x. So these are unlike terms, although they have a common factor x, but the algebraic factor y is not present for the term 4x, so they are unlike terms. Now let's try and understand monomials, binomials and polynomials. You must have heard of these terms. You might not have used them as such. Now let's try and understand what are these. Expressions containing only one term with a non-zero coefficient are called monomials. Now this is important. First of all, the expression should have only one term, and that term should have a non-zero coefficient. So if we have an expression of the type 0x, that will not be considered as monomial, because the only term that we are mentioning here has zero coefficient. So terms like 5x square, 9y cube, 3z, 4, etc. are all monomials. And note here that even 4 is a monomial, because it does not, although it does not have a variable, but it is one term with a non-zero coefficient. Expressions containing two terms with non-zero coefficients are binomials. Again, it has to have non-zero coefficients here. Examples are 5x square plus 9y cube, 3x square minus 7z, 2x plus 6. All of them have two terms, and both the terms have non-zero coefficient. So if we take 9x square plus 0y cube, it will not be a binomial, because 0y cube is essentially 0. It is not a term. So the only term would be 5x square. So that would come under the category of monomials. Now, expressions containing one or more terms with non-zero coefficients with the exponent of the variable being non-negative are called polynomials. Now here we have two important things. First is that it should be non-zero coefficient, and the second thing is that the exponent of the variable should be non-negative. So that means it should have more than one or more terms with non-zero coefficients, which is like monomial and binomial also satisfy that criteria, and the exponent of the variable is non-negative. It could be 0, it could be any positive number, but it cannot be negative. So they are called polynomials. The example is 9x square plus 5x square plus 9y cube, 3x square minus 7z, etc. Now try and understand here 2x raised to power minus 4 plus 6y minus 8, or any expression like 1 by x plus 4x. These are not polynomials, because they have a negative exponent of the for the variable x. So here if we are saying 1 by x, this is equivalent to saying x raised to power minus 1. So these are not polynomials. Now how do we find the value of an expression? we can, as we said, algebraic expression is something that contains a variable, and that variable can take any value depending upon the context of the mathematical problem. So we can find the value of an expression only if the value of variable is given to us, because that would mean that we are given the value of that variable in that mathematical context, and that is where we can find out the value of the expression again in that context. We can find the value of the expression by replacing the variable with its value. Now let's see it. How do we do that with an example? For example, we have an expression of the type 3x square minus 4y. Now we are supposed to find the value of this expression when x is equal to 2 and y is equal to 1. And note that these two things are given to us. These two things are provided to us in a particular context. So now let's replace the values of x with 2 and y with 1. So it make 3x square becomes 3 into 2 square minus 4 into y being replaced by 1, we say 4 into 1. So this becomes 3 into 4 minus 4, that is 12 minus 4. That gives us the value of this expression as 8 when x is equal to 2 and y is equal to 1. Now please note that this expression will have different values depending upon the different values of x and y. So this expression is equal to 8 only when x is equal to 2 and y is equal to 1. If we interchange the value of x and y, let's say we take x is equal to 1 and y is equal to 2, then we put that value in this expression and we say it becomes 3 into 1 square minus 4 into 2, that is 3 minus 8, and the value of the expression will become minus 5. Now let's try to understand, where are the algebraic expressions used? We use them very much in our daily lives. Let's take a few examples from our daily life to understand how do we actually use them. First of all, supposing you need to go to the market and get 2 pens, 1 eraser, 5 sheets, 5 color pens. How do you calculate the money that you need for this? We can create an expression of the type that 2p, where p is the cost of the pen, plus e, where e is the cost of the eraser, plus 5s, where s is the cost of the sheet, plus 5c, where c is the cost of the color pens, and that will give you the total cost. Now supposing last minute you decide that you want to take a different pen. You don't want to take the pen that you decided to take in the beginning. Now you want to change the pen that you want to take. So now the expression remaining the same, just change the value of the p to the new value, and then you'll get the total cost using the same expression. So that is one of the applications where you will see that you use algebraic expressions in our day-to-day life. Let's look at another example. Say for example you have 5 squares, 2 rectangles and a circle of given dimensions which are to be painted. Now how do you find out the total area which needs to be painted so that you can decide on how much paint do you need to get? Now first of all, if you have to find out the area of the square, that itself is an expression when we say area of the square is equal to a square. Similarly, finding the areas of rectangle and circle itself is an expression. Now finding the total area, we make an expression of the type 5a square, where a is the side of the square, plus 2lb, where lb are the length and breadth of the rectangle, plus pi r square, where r is the radius of the circle. So now using this expression you can find out the total area and then find out how much paint is required to paint that much area. Let's take another example to get more clarity on the usage of algebraic expressions. Say for example on your birthday you want to party with your friends in the school canteen. Now, you can only take a fixed amount of money to the school because your school has a maximum cap of how much money can be taken. They allow you to take, say for example, 200 rupees to the school at the most. Now, how do you calculate what snacks can be taken for the party for how many friends? Now, you can create an expression. Say for example, you decide you want to take 5 friends along with you, and you decide that per person you want to buy juice, ice cream, or maybe some snacks, and then find out using the expression whether you can get all of that and that much money. And if you can do that, and then finally you decide, oh, I'm left with some money and I really want to get 2 more friends of mine into the party, you can involve them also. You can call them for your party, And then if again, you using those expressions, you could also decide what you want to add to your party, or if you can remove one of the things to the party and you can add more friends to it to make it more fun. So those are the kind of things that can be handled using expressions. And of course, there are many more examples from our daily life where we keep using expressions without actually knowing that we're using them. Let's now take a look at how do we perform addition in the algebraic expressions. So first of all, it needs to be very clear that all the normal arithmetic rules are to be followed here also. The only difference that comes in case of addition of algebraic expression is that we handle the like terms together and we handle the unlike terms separately. For performing addition, we simply put the expressions side by side with an addition sign in between the two expressions as expression 1 plus expression 2. And if we have more such expressions to be added, we can just say expression 1 plus expression 2 plus expression 3 and so on. Realign all the terms to bring the like terms together. Add the like terms to each other and we get the final answer. We'll take an example to see how do we perform the addition on the expressions, but let's first look at an analogy. Say for example, I already have 2 burgers with me and my friend gives me another burger and french fries. Now if I were to tell what do I have in all at the end of it, I will say that I have 3 burgers and 1 french fries. I will not say that I have 4 burgers, or I will not say I have 4 french fries, because I am not performing simple addition. I am performing an algebraic expression addition. So what I do here is I say 2b for burgers plus the second expression being b plus f for french fries. So that makes it 2b plus b plus f, and that makes it 3b plus f. So I add 2 burgers to 1 burger which are like terms, and 1 french fries which is unlike term is handled separately. So similarly, now let's look at how do we perform addition on these two expressions. We just put them with an addition sign in between them, and now we rearrange the like terms and we make it 5x square plus 3x square plus 9y cube minus 7z, and simply add the like terms and it becomes 9x square plus 9y cube 8x square plus 9y cube minus 7z, and that's the answer for the addition of these algebraic expressions. Now for performing subtraction, we put each expression in brackets and then put a negative sign before the second expression which has to be subtracted from the first expression. So we say expression 2 is to be subtracted from expression 1. So we say expression 1 minus within brackets expression 2. Now use the arithmetic rule to open the bracket. Simple arithmetic says when there is a negative sign outside of the bracket, then if you have to remove the bracket, you change the sign of each of the terms within the bracket. So the same thing we'll do here. While opening the bracket, after the negative sign, the positive and negative sign of each term will be reversed. Again, this is as we do in arithmetic. Realign all the terms to bring the like terms together. Add or subtract the like terms to each other and we get the final answer. Now let's take an example. We have to subtract the expression 3x square minus 7z from 5x square plus 9y cube. So now this 3x square minus 7z becomes the second expression. So now let's try to make it like 5x square plus 9y cube minus, then within the bracket we say 3x square minus 7z, and now we try to open the bracket and it becomes 5x square plus 9y cube minus 3x square plus 7z, and realigning it becomes 5x square minus 3x square plus 9y cube plus 7z, and the final answer would be 2x square plus 9y cube plus 7z. So now this example, again, burger and french fries example again shows the same thing, that if you have 2 burgers and 1 french fries and somebody wants to take one burger and one french fries from you, you're left with one burger. Now you can't say I'm left with one french fries or I'm just left with one thing. Now we're not talking about thing here, we're talking about an expression. We're talking about what one thing are you left with. So you'll have to specify one burger. So that means the like terms, you subtract one burger from two burgers and you subtract one french fries from one french fries. Now let's move on to the quiz on algebraic expression. The first question goes like this. You have to tell which of these is not a polynomial. X raised to power 4 plus 6x plus 1, x raised to power 3 minus 3x square minus 5x plus 1 by x square minus x square, 1 minus 5x raised to power 6 plus x raised to power 8. We'll go to the solutions after all the questions. The second question is, find the value of the expression 4x raised to power 4 minus 9x cubed plus 2x square minus 9x plus 1 for x is equal to 2. So here are the options. And let's move on to the last question of algebraic expressions. What should be added to x square plus xy minus y square to make it x cubed plus 5xy? And here are the choices. Now let's try to look at the solutions for these questions. The first question, which says which of these is not a polynomial. So the first term is x raised to power 4 plus 6x plus 1. Now it clearly has three terms with non-negative exponents of x. So this is a polynomial, right? We only had two conditions for a polynomial, which is an expression which has one or more terms with non-zero coefficient and it should have non-negative exponent of the variable. So both these conditions are met. So this is clearly a polynomial. Now x cubed minus 3x square minus 5x plus 1. Again, this is four terms with non-negative exponents of x. So this is also a polynomial. 1 by x square minus x square. Now this can be if you see, can be represented by x raised to power minus 2. So this has a negative exponent of x, so this is not a polynomial. And 1 minus 5x square raised to power 6 plus x raised to power 8, again this is three terms with non-negative exponent of x, which is a polynomial. So the answer clearly is option C. Let's look at the solution for question 2. It says we have to find the value of this expression when x is given to be 2. So let's now replace all the x's with 2 in this expression. So we get 6 into 2 raised to power 4 minus 9 into 2 raised to power 3 plus 2 into 2 square minus 9 into 2 plus 1. So simplifying, we get 6 into 16 minus 9 into 8 plus 2 into 4 minus 9 into 2 plus 1. And that makes it 96 minus 72 plus 8 minus 18 plus 1. And the answer is 15. So option B is the correct answer. Now let's look at the last question, the solution of the last question. What should be added to x square plus xy minus y square to make it x cubed plus 5xy? Now as we do in the arithmetic operations, we'll subtract x square plus xy minus y square from x cubed plus 5xy. So doing that again, for subtracting, we put the first expression minus the second expression, where both the expressions are put in the brackets. Now let's open the brackets and it becomes x cubed plus 5xy minus x square minus xy plus y square. And bringing the like terms together, it becomes x cubed minus x square plus 5xy minus xy plus y square. And that becomes x cubed minus x square plus 4xy plus y square. So this term should be added to x square plus xy minus y square to get x cubed plus 5xy. So option A is the correct answer. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.